On Earth, it's impossible to go very long without seeing the sun. This enormous ball of atomic fire rules the sky because it is the largest body in the solar system. The sun isn't that enormous for a star. In fact, it's about average in size, yet it dwarfs anything nearby. The sun appears enormous from our vantage point. However, it does not appear to be as large when viewed from the outer reaches of our galaxy. So, are there any larger stars in existence? Absolutely. Our sun is a yellow dwarf, which is a little smaller than the normal star in size. The big stars make our sun appear insignificant. So, what is the biggest star ever discovered in the universe? How big and frightening can they really get? Let's find out. Our sun receives a lot of attention in terms of stars. Life on Earth practically revolves around it, and from our vantage point at least, it dwarfs the other stars in the sky. The sun appears smaller when viewed from the remote reaches of our galaxy, though in actuality its size is rather typical. First, let's talk about stars. There are many distinct kinds of stars. Some are bigger than others. However, before moving on, you must realize that stars don't have neat, defined boundaries. They do not have a rocky planet or a moon's solid surface. Instead, the superheated mass of gas that makes up these atomic bodies slowly thins out into nothingness, leaving them with somewhat dispersed surfaces. A star's photosphere, which is the point at which the star turns transparent, is what astronomers use in place of a surface, i.e., where photons can escape the star. So, from now on, be aware that when we refer to a star's surface, we actually mean its photosphere. The second crucial point to keep in mind is the fact that we have never directly measured a star. Nobody went up to one with a ruler and started adding up distances. We do, however, have estimates, mostly accurate estimates, but nonetheless estimates. These estimates can be more or less precise and fall within a smaller or larger area of confidence depending on a variety of factors such as distance or structures around stars or between them and Earth. I.e., we know it's between X and Y miles or kilometers wide. You might recall learning in a science class in school that the sun is actually a star rather than a planet. The sun can appear enormous when you stand outside throughout the day and look up. You can conclude as a result that it is the biggest star in the galaxy. However, Ui Scuti is hundreds of times bigger than the sun. The sun appears larger in part because of its proximity to Earth. Although the sun is a huge star, it is not by any means the largest star in the cosmos. What is the largest star that has been discovered in the universe? The answer depends on whether you're referring to a star's mass or total volume, or how much space it occupies. According to Phil Massey, an astronomer at the Lowell Observatory in Flagstaff, Arizona, when it comes to size, the heavier stars are frequently unimpressive, while the most massive stars are frequently faint. That's because older stars have the propensity to expand and lose mass. The tallest people might not weigh the most, Massey added, comparing it to humans. Consider that you are discussing mass. The star 136A1 holds the record. It is situated in the Large Magellanic Cloud, a tiny galaxy that revolves around the Milky Way, around 160,000 light-years away from Earth. Imagine a cherry next to a gigantic yoga ball that is more than 2 times more massive. This star is 30 to 40 times the size of our sun in terms of diameter. This star is also quite young, having lived for only 1 million years, as opposed to our sun's 4.5 billion years, and hasn't done any cooling off or expanding. There are several contenders if the definition of the largest star in the universe is the one with the largest diameter, and Ui Scuti is at the top of that list. Astronomers at the Bonn Observatory in Germany first noticed it in 1860 and gave it the designation BD 125055. After more observations revealed that BD 125055 changes in brightness and magnitude over the course of 740 days, it was determined to be a variable star. The diameter of this red hypergiant is approximately 1,700 times that of the Sun. Remember that supergiants are bigger than giant stars, while hypergiants are bigger still. Hypergiants are extremely rare and have dazzling lives. Additionally, they lose more mass to stellar winds than smaller stars do. If Ui Scuti were to replace the Sun as the primary star of our solar system, its photosphere would reach beyond Jupiter's orbit, giving you a sense of its size. Jupiter and the Sun are separated by 484 million miles or 779 million kilometers. A long nebula would be formed by gas coming from the star. 1 astronomical unit, AU, is the distance between the Earth and the Sun, and this would effectively extend well beyond Pluto's orbit. The average orbiting distance between Pluto and the Sun is 39 Australian dollars. Uy-Scuti would be a spherical 10 stories tall if the Sun were a cherry. But measuring the diameter of very far-off stars is fraught with uncertainty. Uy-Scuti is located in a constellation Scutum, otherwise known as the Shield, approximately 9,500 light-years away from Earth, give or take 1,000 light-years. The biggest stars seem brighter up close and dimmer at a distance. Astronomers must know how much light the star produces to do this. You end up with a wide margin of error when you combine that with the fact that red hypergiants like Uy-Scuti are frequently variable, meaning their brightness changes over time. Variable star sizes frequently change as a result of variations in brightness. For instance, according to research, the radius of Uy-Scuti may be up to 192 solar radii greater or smaller than previously thought. If the lowermost value is accurate, other stars would be larger than Uy-Scuti by about 30 times its smallest estimated size. Red hypergiants are difficult to model because of their extreme messiness. According to Massey, the surfaces are always moving. On the other hand, WO-G64 might be the biggest star in the cosmos if it weren't for Uy-Scuti. Approximately 170,000 light-years from Earth, WO-G64, at 1,154 to 1,730 solar radii, is a red hypergiant in the Large Magellanic Cloud in the constellation Dorado in the skies of the southern hemisphere. This star's brightness varies over time in part because of a dust cloud in the form of a torus that blocks out some of the star's light. The star most likely created the torus while it was dying. Additionally, there is VY Canis Majoris, which is 8.2 million years old. Originally thought to be between 1,800 and 2,200 solar radii in size, the red hypergiant star VY Canis Majoris has since had its estimate revised down to 1,300 to 1,540 solar radii. The diameters of WO-G64 and VY Canis Majoris are both about 1,500 times larger than the Sun. Furthermore, either could surpass Uy-Scuti in size, given the ambiguity.